Perfect.
Hi, everyone, and good afternoon to our FCI seminar series. We are close to 1 p.m. Eastern Time, so just get yourself situated, welcome on in, and we'll get started promptly at 1 p.m. Thank you all. All right, it is 1 p.m. Eastern Time, so let's get started. Welcome and good afternoon, everyone, and welcome to our FCI seminar series for August 2023. I am your host for today. My name is Demina Galmore-Wilson, and I am the research manager for the Cabal Martinez Lab. And I'm joined today by Ms. Hegla Aranda Garcia, the FCI team administrative assistant. Dr. Caban and Dr. Sali send their regrets for today. Dr. Caban is at Boston for a technical committee meeting. And Dr. Sali is on maternity leave, returning September 5th. Don't worry, we are counting down the days, just waiting for her return as well. Just a couple administrative points before we get started for today. So please put yourself on mute. For those who've already done that, thank you so much. And please stay muted throughout the presentation. And please provide any questions or comments in the chat via the Q&A section of the webinar. At the end of today's presentation, I will ask your presenter the questions that you put in the chat, so we'll be pretty organized. Today, we are in for a very special treat as one of our FCI's student trainees, Ms. Shruti Choudhary, is presenting. Shruti is a doctoral student of Chemical, Environmental, and Materials Engineering in the College of Engineering and is presenting with us today. She works under the mentorship of Dr. Biswas, who's a dean and professor of the College of Engineering School, who's also the director of Aerosol and Air Quality Research Lab. Shruti is an active student member of the Center for Aerosol Science and Technology and Firefighter Cancer Initiative at where she's mentored by Dr. Carban Martinez. Her research involves development of next-generation aerosol sensors and evaluating health and safety in indoor, outdoor, and space environments. Please join me in welcoming Shruti Choudhary for today. Thank you, Shruti.
Thank you so much, Ramina, for the kind introduction. Just for the confirmation, can you confirm if I'm audible?
Yes.
Okay, thank you.
Thank you.
Hello, everyone. Just right before starting, I want to acknowledge that it's been a great collaborating with the Firefighter Cancer Initiative. So today, we would be talking about aerosol emissions from Firefighter Gear, one of the case study from Firefighter Cancer Initiative. Okay, so before I jump into other stuff, let's talk about what aerosols are. And the outline for the presentation would be aerosols, what are the firefighter exposures, past studies and research gap, and the objectives of this study. And then we have two objectives for this talk, objective 1, objective 2, followed by the summary. So aerosols, the first word in my title was the term aerosol. So before jumping into the results and the methodology, I want to quickly explain what aerosol is. So aerosol is particles suspended in air. If you want to visualize how they are, you can think about a hair strand. And then if you see these blue dots, these are your PM10 particles. And then if you again zoom in and you see those red dots that are PM2.5, but if you compare that with the fine beach sand, then it's a little larger. But anything that is in the air, it's an aerosol or particle. And they are present in different shapes, sizes, and chemical composition. One thing to be noted is that aerosol is not gases present in the air. So oxygen, nitrogen, all those gases, the one that we breathe, carbon dioxide, methane, they are not aerosols. But aerosols are the particles that are suspended in the air. All the way, aerosols are used in drug delivery for cancer treatment, making new medicine, for synthesis of advanced material for energy applications like energy storage, and also for agriculture. While aerosol science has been proven beneficial for such cases, aerosol science also helps in understanding the exposure of the aerosols that are released or are present in the environment. So for this seminar, example is like aerosols or smoke pollutants that are released during the firefighting activities, or maybe just about how the airborne transmission of infectious diseases occur. So the big picture is that firefighters are exposed to high concentration of toxic aerosols and gases during firefighting. A recent study which compared the from the Florida Firefighter Cancer Registry data, it shows that compared to general public, firefighters contract 55% more skin cancer, 36% more prostate cancer, and they are likely to get 2 times more for the thyroid cancer. And based on many such evidences, the International Agency for Research on Cancer reclassified firefighting as Group 1 carcinogenic profession. We very well know the IARC monograph, volume 132, which explains the occupational exposure to a firefighter. and there has been many strong mechanistic evidences that support the exposure to the firefighter. And those exposures can be from combustion products, diesel exhaust, building material, asbestos, chemicals, shift work, or ultraviolet radiation. For today, we would more be talking about aerosols. So in aerosols, you could have anything related to combustion products, diesel exhaust, building materials, asbestos could be a part of the aerosol, and all the chemicals that could be scavenged onto the aerosol particle. So during a firefighter shift or a training scenario, they could be exposed in many different environments. So, like, let's say if the firefighter is at fire station, they would be working, sleeping, eating, bathing, cooking. Cooking might release aerosols. The diesel exhaust from fire trucks will emit aerosols. But then, if you have HEPA filters or the filters onto the fire truck itself, we are less likely to inhale the diesel exhaust. Another aerosol emissions would be from firefighting and rescue missions. Okay, so in the past, there has been many studies that has looked into fire training, aerosol exposure at fire stations, and wildfires. So some studies have said that firefighters can be exposed to high concentration during fire training, as high as 17 milligrams per meter cube. To give you what this number means, it's same as if you go back 50 years, if you go back and if you see a coal power plant and if you see the smoke coming out, that is almost same as 17 milligrams per meter cube. Another study said that ultrafine and respiratory particle exposure are prevalent during vehicle fire suppression. And then some say that there are some different types of instrument that you can use during firefighter overhaul operation to monitor the aerosol concentration. Another studies that has been done specifically inside fire stations say that specifically in rest areas like kitchen, the concentration could be as high as 155 micrograms per meter cube. It's less than 17 milligrams per meter cube, but it is still on a higher note. One of the recent studies that came out from Portugal, they say that bar, PPE storage room, common area, garage, they might have concentrations maybe exceeding 300 micrograms per meter cube. And some studies that were done with wildland firefighters, they say that they could be exposed to concentration as high as 1.75 milligrams per meter cube. So overall, they say that firefighters are exposed to high concentration, and then they should wear the SCBA mask as necessary. But we still identified research gaps that we need to address. One of the gaps was what is the role of particle resuspension in exposure to firefighters? So we know that recently there has been many more protocols about cleaning the fire gear once you are done from the fire training. So another gap for us is what is the quantitative assessment like on the on-scene gross decontamination efficacy after fire training on reducing the aerosol that are resuspended during gear doffing. And gap 3 is we really lack the data of how the aerosol emissions look inside fire trucks due to firefighter gear. Just as a quick note, whenever if you're coming out from a firefighting activity, so many particles are sticking onto the firefighter gear. And then when the firefighter starts doffing off the gear, those particles resuspend. And that is the major, a major objective of these studies over here. So the first objective of our study is to look at the quantitative assessment of on-scene gross decon efficacy after fire training. And the second objective is to perform real-time measurement of particles in the fire trucks and firefighter personal vehicles to estimate aerosol exposure from firefighter gear. Just a quick background as to how did we reach as to like aerosol resuspension from firefighter gear is also important, is that back in 2021, when we were looking at the fate of aerosols and their transport in the fire training environment, we found that some peaks were attributed to when the firefighters were doffing off their gear. So basically, this green graph that you see over here is the particle concentration that was measured when firefighters were doffing off their gear. And that time the instrument was placed at a very high distance as from where the firefighters were doffing off their gear. But we still wanted to look further as to, because when firefighters are doffing off their gear, those aerosols would be in the vicinity of the firefighters. So that made us look more into what's going on in a detailed format. So first objective is all about on-scene gross decontamination efficiency. So for that, what we did was we performed real-time particle measurement, size distribution measurement during gear doffing procedure. So we asked firefighters who first wear the clean gear and then doff off the gear. Another case was gear without decontamination. Just to be clear, just for the clarification, decontamination here is cleaning the firefighter gear with soap and water. And then another case was gear with decontamination. And then we also looked into when those particles are released, in what part of the human respiratory system would they deposit, and what region would they deposit, and in how much percentage would they deposit. So the first objective went this way, that we had a chamber and then we placed all our aerosol measuring instruments inside the chamber. And then one by one, firefighters used to get inside and then they used to doff off their complete gear inside the chamber and then get out of the chamber. And this study was done for 5 different fire trainings on 6 different firefighters. So first, here I just want to show 2 instruments that we are using for this study. One is SMPS and another one is GRIM. SMPS stands for Scanning Mobility Particle Sizer. So it gives us detailed size distribution of particles in the size range 3 nanometers to 1 micrometer. So it's almost like if you take your hair strand and then you keep on separating them by the time they get to the nanometer scale. And another instrument was GRIM aerosol spectrometer. It measures aerosol mass and number, but on a higher size range. So it's from 280 nanometers all the way to 32 micrometer and beyond. So when we first started looking into the number size distribution as to how many particles are being emitted and in what size range, and how does that story looks for when the firefighter is doffing off a clean gear versus when they are not decontaminating. So you will see over here, the black curve is when the decon was performed, and the red curve is when the decon was not performed. So you'll see that the concentration and the number of particles that were being released, they did reduce. But then there was another case where if you look at this pink one, which is without decon, it is just slightly higher than the dark pink, which says that it's not necessary that the small size particles might come off when you are doing gear doffing with decon. And just for the comparison, this blue curve is the air, the ambient air. So you can see particles being emitted in the environment while doffing off the gear. And all these fire trainings were happening with a Class A fire. Now, so this was all about the number of particles that were being emitted. We then also look for what is the mass concentration of the particles that is being released, like how much mass per cubic meter of the air of the aerosols are occupying in the ambient air. So we looked into 3 different cases. First case was total suspended particles. So it's all the aerosols. PM10, it's all the particle, it's the mass of the particle having size less than 10 micrometer. And PM2.5 is mass of the particle having size less than 2.5 micrometer. So in all the cases that you would see, there was a decrease in particle concentration after decon, for sure. So all the bars that you see with the stacked lines, these are without decon, and the one which do not have line, they are with decon. So when we looked into all these 3 scenarios, we found that there was on an average 87% decrease in the total suspended particles that were released after gear decon. Whereas for PM10, it was 82%, and PM2.5, it was 70%. Again, this was associated with a higher variability, but then you can see that as you're reducing the size of the particle, less the efficiency is reducing. But still, it's significant for somebody to be less exposed to those aerosols. And then we looked at what percentage of those particles are depositing in what region of the respiratory system. So based on that, we looked into in the head airway region, which is your nasal, pharynx, and larynx. Then you have a tracheobronchial region, which is this green region over here, which includes trachea and bronchi. And then we have alveolar region, which are all related to the alveolar ducts and sacs. So you'll see that of all the particles that were being emitted without decon, 68% mass of the particle was being deposited onto the nasal, pharynx, and the larynx region of the respiratory system. So most of the particle mass is being deposited over here, but you could still see that there's 0.0001% of mass that is being deposited in the alveolar duct. To mention over here, if your particle size is very small, like if we go into the nanometer scale, the mass of the particle would also be very small. So that percentage would be less, but still the particles that were being released, they would deposit onto the alveolar region as well. The second objective was to perform real-time measurement of the particles in the fire truck and firefighter personal vehicle. So in this case, we collaborated with the Lauderhill Fire Department, and then we asked them that, would it be possible for you to place the sensors in your cab, near the passenger seat, or in your personal vehicle to see how aerosol emissions looks like, and are there any exposure to the firefighter after they're done with the training or if they are coming back from the firefighting site. So the study design was that we first obtained the verbal consent from the firefighter about the study and the use of the sensor and survey form for data collection. And then we showed them what is the operation of the sensor and how to hand the sensors. And then we finally gave those sensors to the firefighter who were interested in the study. And then we also explained the survey form. So you can see that it's a palm-sized sensor which firefighters can carry with them. And then they can use it in the fire trucks or in their personal vehicle, wherever they would want to. And this was the survey form that was required to be filled by the firefighter. And it tells us that what place they were, like, was it fire truck or was it personal car? And then where was the sensor placed? Where was the gear placed? Was the gear clean in the past 24 hours? And has anybody smoked or waved in the car? Because that could influence the aerosol concentration, and we might not get the correct data for the aerosol emissions from the firefighter gear. And then do your car have car freshener? Because all those would lead to increased aerosol concentration. Then we looked at the date, the sensor start and stop time, the firefighter and the vehicle start and stop time. What was the type of ventilation inside the car or the fire truck? Was the window open or closed? Did they stop somewhere? All those factors were associated when filling up the survey form. And then just at the prelim data as to how it looks like, we found that for the case of fire trucks, there were two cases when the firefighters placed the PPE at the feet on the floor of the fire truck, and they were also wearing the sensor on the radio strap, and they were sitting on the passenger seat. We found that the concentrations were a little higher. There was another case where PM1 and PM10 were on a higher note, because we would want the concentration to be as low as possible, like less than 5 micrograms per meter cube is particularly desirable. The first two cases were about fire trucks, but the another three cases were in the personal vehicle, and we found that the concentrations were really low, which sort of gave us the reassurance that inside the fire vehicle, inside the personal vehicle, the firefighters are not exposed to the aerosols that could be coming from the gear, because the gear was placed in the rear cab. So it was like, it's good that the firefighters are not being exposed. But in fire trucks, the case was a little opposite, because the firefighter gears were inside the fire truck and they were just placed right next to the feet. So that could have associated with the increase in the PM concentration inside the fire truck. Then if I show you how the temporal variation looks like how does the concentration looks like over the time scale? So just on an easy note, if you look at the figure onto the right, you'll see that concentration was high and then it started reducing. And this was the case when the sensor was inside the fire truck, and then the PPV was also inside the fire truck. So you can see that concentration was high, and then it started reducing and getting back to the 5 microgram or even lower levels after 1 hour. So this could be that that AC was on. So AC, because air recirculates, also that cleans up the aerosols that are present inside the fire trucks. So that could be the case, but this clearly shows that it takes almost 1 hour for the particles to get to the baseline or lower concentration levels. And then there was another case where we did not have the complete data, but we could still see that the concentrations were higher initially, and then they started decreasing and getting to the lower levels. So just to summarize, firefighters are more likely to inhale toxic aerosols without SCBA mask for sure. Exposure to toxic aerosols from secondary emissions and aerosol resuspension is evident in fire trucks from the preliminary data that I just shared. We did not see any increase in aerosol concentration in the firefighter personal vehicle. The gross decon reduces particle emission by 87%, 82%, 70% for total suspended particles, PM10, PM2.5 respectively. And 68% of the aerosol mass that is being emitted during gear doffing without decon gets deposited in the head airway region, that is nasal, pharynx, and larynx. And with that, I would want to thank you all. These two pictures are two collaborative objectives that we did. The first one was with Parkland Fire Department. On the left, you'll see Lieutenant Frank Pecora, and another study being done with Lauderhill Fire Department with Chief Maxey. So with that, I am open for questions, and thank you so much for listening.
Absolutely. Shruti, that was amazing. Thank you so much for sharing. So Shruti just presented a case study of the aerosol emissions from Firefighter Gear. Obviously, this is from our FCI initiative project here. So while we are thinking of some questions, I'll allow like a couple minutes here, and for us to ask any questions that we have for the presenter. You could go ahead and put that in the chat, and I will read that to the presenter, and that'll be wonderful for us. I also have a couple updates and announcements to share in a couple minutes after we go through Q&A sections as well. I do want to say thank you to everyone who has joined our session today. I did see a couple of names of firefighter personnel, so thank you all for hopping on and for listening in today. All right. So while I wait for questions to be populated in the chat, I did want to share a couple of reminders with us for today. Next month is our next seminar series date, where we will have Dr. David Lee. He is a professor and chair of the University of Miami Department of Public Health Sciences, Division of Epidemiology, Population Health Sciences. So he'll be presenting with us next month. So save the date. It will be next month on Tuesday, September 26th at 1 p.m. I will pause. I do see a question from one of our guests regarding the firefighter personal vehicle testing. Where exactly was the PPE placed?
So for the personal vehicle testing, the gear was placed in the cab. So like in the trunk of the car, and nothing in with the firefighter.
Wonderful. Thank you, Shruti. We have another question. Can you explain again the graph in slide 10 where those measurements were made?
Okay, let me go back to slide. Okay, this slide over here. Okay, so these measurements were done at the fire training site at Coral Springs Fire Department. These measurements were done back in April 2022. So to quickly explain, we had the firefighter wearing the sensor, the small sensor that I showed you in the later slides, and some sensors were kept in the proximity. So a few sensors were being worn by the firefighters and a few sensors were in a far away zone or the cold zone. So the first red graph that you see over here, it's associated with firefighter inside the room, like in the hot region. And then in that region, the concentrations are like 4,000 or 5,000 micrograms per meter cube. Then there were certain reductions in the mass concentration. That was because when window was being open or door being opening, and then a sudden decrease, which was when the firefighters came out of the room. So like no concentration after that. So that was the red graph. The blue graph is the far away region. So it's this cold zone. You'll see that concentrations are pretty low, but it's only when if the door gets opened. There was one incident we saw a peak, which was associated with the smoke being traveling to the faraway zone. And then this green curve is associate, like it was again in the faraway zone, but it was somewhere like 5 feet in the proximity where the firefighters were docking off their gear.
Very well. Thank you, Shruti.
Does that answer I hope that answers the question.
I think so, but thank you. We have another question from one of our guests. In cab over fire engine design, the motor is housed under the cab of the fire engine. When the interior panels are removed from the cab over engines, there's large amounts of diesel particulate found behind the upholstery panels. I don't doubt that the gear is an issue. I believe the inherent design flaws in the cab over design, leaking particulate into our cabs, is exposing firefighters on a regular basis to particulate exposure. That was really a question and a comment for you, Shruti.
Okay. So from what I understand is that it's the particles from the diesel exhaust emissions that are leading to increased concentration rather than the firefighter gear themselves. I think you made a really good point. This is something which, when we do more experiments, and because this study is still ongoing, I would take care of that and see if the particles are exactly from the diesel exhaust or from the firefighter gear. Thank you for the
Perfect.
point.
Absolutely. And thank you so much, Rudy, for your response. Another question for you. Based on the preliminary results, other than gross decon, are there any recommendations for keeping air circulating or other way to reduce the exposure for firefighters?
Okay, so first, gross decon is one of the first line of defense, because that way you can remove majority of the particles. But then the second case is maybe doing doing the decon. So first is that somebody who is doing the decon, they should also wear the SCBA mask, other than the firefighter who are wearing the SCBA mask. The second one is doing in a region where airflow is high, or doing in a region where the air exchange rate in the room is higher, so that you can reduce the exposure. And the third one is using the HEPA filters themselves, because HEPA filters tend to absorb many particles, so you can further reduce the particles. Also, I am not sure if mask would be an easy option, but if possible, if firefighters can wear the mask, that would also be another line of defense.
Very good response. Thank you, Shruti. And I think we have one final question for you for today. First, a comment for you, Shruti. Very nice presentation today. Can you explain how the mass deposition in the lung was modeled or calculated? Have you calculated what the deposited dose in the deep lung would be given a typical aerosol exposure?
Okay, so in order to calculate the mass deposition in the lung, I used ICRP model. ICRP stands for International Commission on Radiological Protection. So they have some set of equations that are derived from experiments, which tell us if you have this size of particle that is being emitted, and in that concentration, how much percentage would be deposited into the respective regions. And then the second question is, have you calculated what the deposited dose in the deep lung would be given a typical aerosol exposure? So I haven't calculated that for now, but this is something I would be working on. So eventually, because we know how much percentage is being there and then I need to calculate for how long would that be. So it would again be a controlled study, but this is something which I look forward to doing. Thank you for the question, though.
Absolutely. Thank you to our guest and to Shruti. With response to response to the question on the cab design issue, the guest also wrote back that they have preliminary sample analyzed, and they believe that this is an issue for the entire fire service. So we'll be, I guess, talking more a little bit with that as well. That was wonderful. So thank you all so much for asking these important questions and for making these comments. We truly learn each time that we engage with you all. So thank you for your commitment to that. And absolutely thank you for your service as always. I think that was our last question. So I thank you all for doing that. I did want to go back to the reminders that we have coming up. As I mentioned, September 26th, Dr. David Lee will be presenting. And also I wanted you guys to remember this and to save the date for Symposium 2024. We are locked in for Friday through Sunday, which would be February 22nd through 24th, 2024. We'll be back at Miami's campus. So bear those announcements in mind, and we look forward to seeing you all again next month. So until next time, thank you all so much and have a great afternoon. Thank you, Shruti.
Thank you so much, Tamina. Thank you to all the attendees for the listening.
Absolutely. Bye, everyone. Thank you.